Welcome back, Algebra 1 students. We are in lesson 40. Can you believe that we are a third of the way through the book already? So pat yourself on the back. We've come a long way and y'all have done some really hard work and I'm very proud of you. So today marks a third of the way through the book. So it's pretty awesome. So let's begin with the quotient rule for exponents. So let's start that by talking about the rules that we already know for exponents. So we know that if we have x times x times x, that the number that we have here is going to equal the exponent that we have here. Okay, and we also know that if x is not 0, given that x is not 0, I don't know why my pen is not letting me draw a 0. If x is not 0, then x times x to the m times x to the n equals x m plus n. And an example of this one is going to be 2 times 2 times 2 equals 2 to the third power. So we have 3 2's here, 3 2's. An example of this one is going to be 2 squared times 2 cubed equals 2 to the 5th power. Okay, because we added 2 and 3. All right, the next rule that we know is that x is equal x to the 1. So anytime we have x by itself, like up here, there's a 1 right here. And if you think about it, that makes this true as well, because if this is a 1 and this is a 1, 1 plus 1 is 2. So the number of x to the 1's is x to the n, but it's also doing the same thing. It's adding the numbers together. So all of this works together so far. We also have learned when talking about negative exponents that if x is not 0, it's very important, then x to the negative, whatever that number might be, is equal to 1 over x to the positive of that number. And the inverse of that is that 1 over x to the negative of an exponent equals x to the positive of that exponent as a whole number. And last but not least, we learned that if x is not 0, then x to the 0 equals the number 1. It equals the value of the whole number 1. All right, that's what we have learned about exponents up until now. If you do not have this written in your notes, excuse me, oh goodness. Sorry, I had a soda earlier and it has been letting me know about it. But as I was saying, if you do not have these in your notes, then it is time for you to write them in there. You need to have a reference of how variables and exponents relate to one another, because we're about to learn one more rule. Let me move this up. And this rule is really an extension of this one right here. This final rule just says that if you have x and m, or x to the m over x to the n, then that equals x m minus n, and it also could equal 1 x n minus m. And if you if you see this, it's the same base, right? It has to be the same base. If you bring n up to the top, n becomes negative, and it is on top over the 1, so it's a whole number. If you bring m down to n, then it becomes negative, and you're subtracting n, or m, from n, and you leave 1 in the top part of the fraction. And now you're subtracting this number from this number. So you can do this in one step. Let me show you an example of that. If you have x squared over x to the 4th, you could easily say x squared minus 4, or if you had x squared to x to the 4th, over x to the 4th, I mean, you could also say 1 over x 4 minus 2. Now, typically, what you want to do is the one that leaves the exponent positive. So in this case, this would be a negative 2, and in this case, it would be a positive 2. This started with the same fraction, and when you look at it, it is the same result because x to the negative 2 is the same as 1 over x to the positive 2, right? So you can see how this rule plays out through this example. Okay, so please write down all of the rules for these exponents. You're going to need to memorize these. You're going to need to know them, okay? And if you don't like my examples, make up your own examples. That's fine. But please, I'm going to actually take my examples and take them out. You can make up your own example if you so desire, but I'm going to move this out of the way so that you can see these better. All right, I'm going to assume that you have had an opportunity to write these down, and I'm going to clear the page. If you haven't, pause and finish if I'm going too fast. All right, we're going to begin with 40.1, and we're going to test out this new rule. So we need to write this answer with all of the x's in the numerator. So we have x to the 6 on top and x to the 4 on the bottom. So we know from our new rule that if we move x to the top in the numerator, which is what this problem says it wants them all to be, we want x in the numerator, that's in the top, then we need to subtract 4 from 6. So this becomes x 6 minus 4, which equals x squared. Okay, let's do 40.2. So now we are asked to write all of these. It's the same problem, but we want to put x in the denominator. For some reason it likes cursive better than it does the other. I guess because it maintains contact, I'm not sure. So we're going to take this and we're going to put the x's in the denominator. So we're going to have 1 on top, and we're going to say x to the 4 minus 6. Now if you need to remember which one is being subtracted, think of it like this. The one that already lives there is going to stay in front. That number stays there. And you are going to subtract the person who is moving, or the exponent that is moving down. He's the one that's subtracted. Or, in this case, the one that is moving up. The one that's doing the moving is going to be the exponent that is being subtracted. So here the 4 moved up. It was subtracted from the 6. Here, the 6 is moving down to the denominator, So the 6 is being subtracted from the 4. That's how you can remember that. Whichever exponent is moving, that is the one that you subtract. So this becomes 1 over x to the negative 2. And if you look at this one and you look at this one, they have the same value because you want to take this negative 2 and move it up. And it would be the same thing, right? Let's do 40.3. In 40.3, we have x to the 6 over x to the negative 4. And we're going to work this problem twice. First, we're going to put it in the denominator, and then we're going to put it in the numerator. So let's do it in the numerator first, just to keep numerator, denominator in the same order. Okay, so let's move everything to the numerator first. So if we're going to subtract the one that's moving, then that means that we have x6 minus a negative 4, right? Two negatives cancel each other out, so this actually becomes plus 4. So 6 plus 4, this becomes x to the 10. And that's when it's in the numerator. I'm just going to put NUM period so we remember. Now when we do it in the denominator, that means we're moving the 6. We have x to the negative 4 in the bottom, and we're moving the 6 down, so we're subtracting the 6. So that's going to give us 1 over x to the negative 10. Same value as this one. Same value, but this is in the denominator, so DEN period, to give you that illustration. So you can see how that works. Whichever exponent is moving, that is the one you subtract. Okay? Don't worry about if it is bigger or smaller than the one that's already there. It doesn't matter. You subtract the one that is moving from the one that is already there. You leave the one that is already there in place, and you just move this one and subtract him. And when you look, you have x here and x here. When we take this x to the negative 10 up to the numerator, it's going to be the same number. Same number. So you see, it doesn't matter which way you take the exponent, or you take your variable with the exponent, whether you move it to the top or the bottom, as long as you follow the rule that the one that gets moved is subtracted from the other one, the one that's already there. Okay, I'm going to write this in red so you'll remember. The exponent I can make that where it looks like the word exponent, that moves is the one subtracted. Okay, remember that the exponent that moves is the one that is subtracted. All right, let's see what else we have in lesson 40. Oh, we have a couple of other illustrations, so let's do those. Those should be pretty quick. So we have 40.4, and this one says x to the negative a over x to the b. All right, we don't have values that we can actually add here. So all we can do is use these little variables in their place. So when we move it to the numerator, then we end up with x to the negative a minus b. That's all we can do. When we move it to the denominator, it becomes 1 over xb plus a. Because this is a negative, we subtract a negative, it becomes a positive. So that would be our answer for in the denominator. All right, 40.5. And this is the numerator, this is the denominator. 40.5, we have something a little bit more complex, so it makes it a little bit more fun, a little bit more of a challenge. Let me write this out, that's a z. And then we have, is that a negative? Yes, -3. All right. And we will find 4 equivalent expressions for this expression. So what we want to do is we want to move it around and combine everything as much as possible. So let's put everything in the numerator first. First, we're going to put everything in the numerator. We're going to bring this up. Let's bring the x up first. So we have x minus 5, and this is a 1, so it's going to become a -1. So a negative, subtract a negative, it becomes a positive. All right, then we have y, and it's a 6 already in the numerator. So we have a +2, so we're going to subtract 2. And finally we have our z, and it's to the 1. And we have a -3, so when we bring it to the top, we subtract a negative, it becomes a positive. So our answer here would be x to the -4, y to the 4, z to the 4. Is that right? Oh, you know what? I didn't do that right. I did not do that right. This should be -5. We bring this to the top, it becomes -1. Oops. It was a +1 down here, so when I brought it up, it should have stayed positive. We just subtracted it. So this should be x to the -6, because I did not do that right. I am so sorry. See, everybody makes mistakes. We just fix them and move on. All right, so let's move this same problem. And I'm going to copy it so I don't have to write it again. Copy. Paste. All right, let's put it right here. Let's do this one in green. This one's going to be moving everything to the denominator. So we'll have 1 in the denominator. When we move x to the -5, let's start with z since it's already in the front. We'll do z. We've got it to the -3. We're going to subtract +1. All right, and then we have y to the +2. We're going to subtract 6. And we have x to the 1. Because this is already negative, we add 5. So this becomes 1 over z to the -4, y to the -6, x to the +6. And if you notice, these are the reverse values. Oh, this should have been a 4. I did it again. I wrote it correctly, 2 minus 6, but I didn't do the math correctly. All right, so they're the opposite sign because they're flipped. One's in the numerator, one's in the denominator. So they should be the opposite exponent from what's up here, and that's correct. All right, so let's do that again. All right. We'll change the color one more time. This time, we're going to write all of the exponents positive, wherever they might be. Okay, so in order to do that, all right, we have an x that's negative here. So when we move it down, it becomes positive. So let's do x 1 plus 5. All right, this y is already positive, and it's bigger than the 2, so when we bring the 2 up, it's going to remain positive because 6 minus 2 is a positive 4. And the z here is positive, and this is negative, so if we bring this up, the positive 1, we subtract a negative 3, we're adding 3. So this ends up being y to the 4, z to the 4, over x to the 6. And those are all positive. And we could do this again, or we could just flip this one to make them all negative. So to make them all negative, we just take x to the top, it becomes negative 6. We bring y and z to the bottom, they become negative 4 for both of those. We just flipped them. So that's how we would do all positive or all negative, denominator and numerator. So as you can see again, whichever one is moving, that's the one that we subtract. And if we're moving a negative, it becomes addition, because when you subtract a negative, it becomes a positive. All right, now let's talk about the distributive property of rational expressions that contain negative exponents. This is going to be fun. Let's clear the page, pause, and take notes if you need to, in case I'm going faster than you. So this is 40.B. This is the second part of the lesson. So we're going to distribute this problem. This is example 40.6. We're just going to jump right in. And we're going to use the same principles that we did with what we just learned to distribute negative exponents. So here is a problem to solve. 4x to the negative 2 over y to the 4. Okay, and we have y to the 4, x to the 2, minus 3x to the 4 over y to the negative 2. Let me double check my numbers, make sure I have everything right. Yes. Okay, so I see that the first thing we need to do is put this over 1 and make it a fraction. Now everything's in the same format, we can proceed. So we draw our line for our first one. Here's our minus sign, and here's the line for our second fraction. We write what we want to distribute first, and then we write the first fraction right in with it. Y to the 4, x squared. And we could put our 1, it doesn't matter. Do the same thing again. We write the fraction we're trying to distribute, and then what we're distributing it to. All right, now we can do the squish. So the first thing I see is that we have x to the negative 2, x to the positive 2. Negative 2 and positive 2 cancel, so they become 0. And now I can see we have a y to the 4 here and a y to the 4 here. Using cancellation, we could just cross through those. But for the sake of looking at the exponents more closely, if we take this 4 up to the top, it's going to be minus 4. And y to the 4 minus 4 is y to the 0. So it goes away. So what we're left with is 4 over 1, which is just 4 here. Now on this side, we have 4 times 3. We want to put our constant in front. That's 12. And we have x to the negative 2, x to the 4. Well, we take our positive 4 and our negative 2 and combine them, and that leaves x to the 2. And down here at the bottom in the denominator, we have y to the 4, y to the negative 2. We combine those, we get 4 minus 2. That leaves us with 2. So our answer is going to be 4 minus 12x squared over y squared. That's as far as we can go with this problem. So let's try 40.7. Let me write it out for us. This is a 2. This is an x right there. All right, so the first thing I see, we have a whole number. Don't get nervous. We just put it over 1. Now everything's in the same format. So now we write our first line, and we write our first fraction that we're distributing. And we can put our 1 in if we want to. Now we put in the first fraction we're distributing, 2. It's going to be y to the 4 and an x squared. We bring down our operation. We put in another line. We write the fraction we are distributing first. And then we put in our second fraction. All right. Now we can do the squish. We have x squared right here, but no x's on top. But we do have an x positive 2 on the bottom. But if we bring this up, it's going to be negative 2 minus 2. That'll be x to the negative 4. If we bring this down, it's going to be 2 minus a negative 2, which will be plus 2. So why don't we do that? Let's move this down here and write this with all the variables. Actually, this says to write all the variables in the numerator. So let's bring the x up. We're going to write all the variables in the numerator. Almost all of them are up there anyway, so why not? So when we bring this up, it's going to be, we're going to get rid of that, and it'll be negative 2 minus 2. So that's going to be x to the negative 4. Then we have y to the 1 and y to the 4 here. That's going to be y to the 5. And we don't actually have this little line because everything's in the numerator. So everything's over 1. Minus, we bring this y up here. This goes away and we say 1 minus 2 because we know we already had 1 here. So this becomes x to the negative 2 and positive 4 becomes x squared and y to the negative 1. All right, and the book agrees we got that right. So we have one more, and I think I can do it right here instead of having to clear the page on you. We are given, let's see, k squared b over p to the negative 2. All right, go ahead and write this down as I write it down so that we don't waste time. I know that you guys don't just love to do math all day, so take the opportunity to write this down. And I'm trying to go quickly, it's just I'm looking back and forth. So it's going a little slow. All right, there we go. And I'm going to draw a little box around this so you can tell where this stops and starts. All right, so now we're going to distribute. I'm going to start right here. We're going to put a line here. And again, k squared b over p to the negative 2. And our first is a b negative 1 over k to the 2. And minus, and we do another line. We do k squared bp negative 2. And then we bring in this second fraction, 4p2b. It's a b, not a 6. I know it could be confusing sometimes with my handwriting. So now let's see what we can combine. So if we bring this 2 up, let's see what it says to do first. All right, this says to put all the variables in the denominator. So if we bring this 2 down to the denominator, it's going to be 2 minus 2, so that's going to go away because that'll be k to the 0. And right now, before we move, we have b to the 1 minus 1, so those go away. So all we have left to bring down is a to the negative 1. Right? So that first fraction is 1 over a to the negative 1, p to the negative 2 minus. Let's look at this one. We know we have 4 in the front, and we are going to actually, we're going to bring that down to the denominator. No, we're not, because only the variables have to go to the denominator, so we can leave the 4 up here. All right, well, we have p to the positive 2. When we bring it down, we're going to subtract 2. So it's going to be p to the negative 4. And we have a b to the 1. When we bring it down, it's going to be 1 minus 1. That cancels, so that goes away. So all we have left is k to the negative 2 when we bring it to the bottom. And the book agrees we got this one right. So as you can see, you just want to cancel what you can cancel and then move the rest. And it just depends on what is the book or what is the problem asking. Does it want all of them in the numerator? Does it want all of them in the denominator? Do whatever it says in relationship to the problem. And that is all I have for lesson 40. So I will see you in lesson 41.